There we go. I just think we just let's just take a moment to just take a breather. Okay, just a little bit. There we go. What is it? What's it doing? Is it doing something? Is it? No, it doesn't look like it's going to do anything. Sorry for the burp. There we go. That's that is a burp sample so high. Oh, and it loops as well. That's pretty good, isn't it? TTE is now bigger than Brainstorm. Well, let's not just leave that looping. That'd be a terrible idea. Right, let's get back to our desktop then. Right, let's. There we go. Let's also close that. Let's close that. Let's put some. I bored of that. And that. Okay, that'll do. There you go. I saw some questions there, so let's just go with. I did see how does the music work. That's the least interesting part of the demo, if I'm honest. It's basically there's a ADPCMB chip on there, and it can do variable rate ADPCM all the way up to 55 kilohertz. So we just threw it all in. So got to polish your motorcycle and start a fight, Ferris. Yes, okay, fair enough. Yeah. Bam. I don't know, mate. As you can see, I've been a bit busy over the last few months. So, yeah. Talk to me in a couple of weeks. Any7, oi, oi, mate. How you doing? Right, so we have some code here. So what I wanted to do quickly first is this diagram's not actually very right. Or on my computer by the seams of it. Hang on. d:/Chrome downloads. Is that where I put it? Is it there? Well, that's fucking rubbish. Hang on a minute. Let's just let me just do that. There we go. I don't want to fire up Discord on stream instantly and then show whatever's there. So let's have a look. I know where it is. Hang on. Now's not the time to be slow, Discord. I sound a bit hoarse. It's because I've been at a demo party for 4 days shouting at people, and it takes me a while to get better. But I'm not ill. I don't feel ill. So, are you off, Rob? No worries, mate. Thanks for tuning in. So let me go here, and then... Christ, we don't have to chat a lot in here, don't we? Scrolly, 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 scrolly. Here we go. Let me just save image. There we go. There we go. There we go. Right, and I can hide that now, and then I can bring you back. There we go. Yay, David. Thank you very much, mate. You sleep. No worries, Truck. See you soon, mate. Wait. There it is. Right, so this probably helps a little bit. It is not 100% accurate, though. So this is kind of a layout, but it's not 100% right. So we've got our 68,000 CPU. It's 12 megahertz. I'm sorry this is white, but here we go. Video display line controller. So this is basically the whole thing that does everything in terms of graphics. Actually, there's nothing on here. So this is just the graphics stuff. It's got nothing to do with the Z80 or anything. So there's 2 chunks of VRAM there. That's basically so the thing to remember about the Neogeo is that, see this game cartridge here, right? So there's all your sprite tiles and there's all your fixed layer tiles, right? They are ROMs, right? You don't load those sprites into VRAM and then display them. So things like the Genesis, the Mega Drive and the SNES, you load your sprite tiles off of the ROM into VRAM so that they can be displayed. That's not how the Neogeo works at all. If you've got a sprite, it's on the ROM and that's it. So there's nothing you can do about it, right? You can't change it. You can't. Also, Game Boy. Okay, yeah. VRAM access on the SNES is fucking awful. So yeah, probably, yeah. So, there's no... anyway, so yeah, so basically anything... It's kind of, there's like a bunch of groups of ROMs. So there's the SROM, you can see there, which is the fixed layer. So what the fixed layer is a character layer, 8x8, that sits on top, completely non-scrollable. So you use that for like head-up display, scores, all that kind of stuff. And then the C-ROMs are all the sprite tiles. So they are 16 by 16 tiles. We'll explain how they kind of work a bit later, but effectively there's fucking loads of them, right? And then that's it. There's no tile layers that you can scroll. There's nothing else, right? There's just, visually, there's fixed tiles, which you can't move. and sprite tiles and lots of sprites. So the only thing that's slightly confusing about this is that this video display controller and the palette RAM. So you've got 16K of palette RAM. So that's, how many was it? 512 palettes, I think it is, that you can reference, which is really good. But what they don't explain is that this is actually the wrong way round. The palette RAM is actually read by the video display controller, and the Motorola 68000 is essentially used to write to it. So, so yeah, then video DAC, blah, blah, blah. So yeah. So yeah, that's kind of, in a nutshell, like that's the biggest challenge of it. You can't just like put a load of sprites in VRAM and create a frame buffer and do lines and vectors and stuff. It just doesn't work. You have to basically create sprites for everything. Everything's basically a sprite. So, which is kind of mental. So yeah. So in terms of sprites, one sprite can be 16 characters, 16 pixels wide, and 512 pixels tall, which is mental. Line buffers, it works by rendering a scan line at a time. So the sprites are rendered, I think it's like a two line process. Furtek did give us a write up about this, and then it's basically like it will grab some info for the first line, and then the second line it will render it, and then the third line, or the line it's actually displayed on, will then display. So yeah, we've got a Furtek there. I didn't see him. Furtek is a legend, yeah. Hopmeister, is VRAM just like sprite pos and sprite control? Kind of, yeah. So, oh, didn't see him either, just spreading love. Okay, fair enough. I mean, we did greet him, but yeah, he did give us a load of info. So I think at a top level, that gives you an idea of how it works. You know, the sprite tiles are completely immutable, right? You cannot change the graphics that are in them, so you have to render out a lot of stuff. But there's other like cool features of it. So the other thing it can do is it can shrink sprites. So you can make them thinner and can make them shorter. And that is essentially just like putting a few values in VRAM and you're good to go. So it's quite cheap to do that kind of stuff. And we actually used that as a trick to get a few more colours. So let me think here. So in terms of sprites, I said they were 16 by 512. They're made up of references of tile ID and some attributes against it. So you can fill those kind of however you want. You can make them as tall as you want. And what you can do is if you put them next to each other like that, you can set the following sprites as chained. So if you have like 120, like 10 sprites across, 15 sprites down, you set everything as chained, and then all you have to do is move one sprite in the top left corner, and it moves the whole lot around. So it's dead useful on some stuff like that. So could you do Doom Engine having? Let's not have this conversation again. After that Twitter debate with that idiot. Well, that might work actually, but it'd be yeah. So this is the other thing. Ojoba said fix sprite priorities. I think you said yes. So the sprite slots start at 0 and go up to 380, and the priority is basically 380 is on the top, and then it works its way down, and it has a horizontal limit of 96, which you think is a lot until you break it and go, oh shit. So so yeah, it's yeah, you can't set a priority with anything. It's just where you put it in the slot in VRAM is the order that it will get displayed. So yeah, there were a few moments where one of the guys in the Discord would go, so we can't change the priority in any other way other than loading it into a different slot. Yes. So as Daniel Collins says, yeah, it's very easy to hit the per line limit. I think we've all done at some point. So right, so let's see build wise. Does it build? I mean, it's already built. Okay, so that's not a problem. So other stuff that's cool, let's just go through some of the tooling first. So we've got here, I didn't build a lot of the tooling. A lot of this was done by Gigabytes and Hooverphonic. So we've got a make file here. It's pretty, yeah, I'm not really good with make, but yeah, I was dragged kicking and screaming into it. So, so the other major things we've got here, actually in terms of extensions, yeah, so we are using, well, the 68K counter, that's essential, you need that. I'm coming, I like the idea of make now, so. So we've got the MAME M68000 debugger adapter protocol. So this was by Hooverphonic, and I think it was mostly by Hooverphonic, but he basically took one of the UAE DAP debugger plugins and then adapted it to work with MAME, which was fantastic. So for example, if we go to main.asm and we just put a breakpoint, say there, let's just do that, and then we just hit F5. You can have everything. We'll release the, yeah, we will be releasing. So at the end of, after, we need a bit of time to like tidy stuff up and determine whether we will or will not do anything with the Neogeo CD. But we are going to release the source code and the tools and everything else. So go and make a Neogeo demo. But here you go. We've got full, basically like the, there you go. We've got basically like full debugging. Oh, that's the wrong mouse. So set breakpoint there. Bam. Okay, yeah. In fact, we could just put a breakpoint there and then run all of that stuff, and then do that, and then ding-a-ding, ding, ding. There you go. So, so yeah. I mean, I didn't build this bit. Hoover and Gigabytes did, but this is my. It's a complete lifesaver for me. Debugging through main that I was going through was rubbish. Yeah, I think I'm going to take a bit of a break plating, if I'm honest. You can also hardware debug with modded controller cable and UniBIOS, by the way. Oh, okay. That might be interesting. Okay. Okay. I might have to have a look at that. Right, so that's our debugger basically. So we can just, it's so handy. And I'm sure you've all seen this before anyway. Obviously, if we do things like circle data, it will show the data at that address. You know, all that kind of good stuff. And the other thing we've got in terms of extensions is the Motorola assembly extension by Gigabytes as well. This is up. That's already up on. That's already up on the extensions where you can just download it basically. And that has one feature that I absolutely love. So let's just go into, say, the parts here, and let's just go to where is it? Scene 1, for example, right? Scene 1. Let's just find load palettes. There we go. Oh no, it's because we're in debug. Okay, right, let's try that again. Oh, it doesn't do, okay, yeah. Bear with, it has to actually be open in a window, doesn't it? So when that file is open, it then grabs that comment at the top and tells you what those properties are that you need to send in. So, so if you go to there, you'll see it's a comment. If that comment is basically just sat at the top of that function name, then you can basically get a tooltip on it to let you know what you need to pass into it, which is super handy. I've used that a lot actually. So modern retro dev, yes, Hop. Right, was there anything else in terms of the, I suppose we could talk about NG tiles. It's a bit hard to demonstrate what it does though, but that's our graphics converter that again Gigabytes wrote. So that will take an image of any size, PNG. If it's 16 colors, then it converts it to a standard 16 color palette, fixed color palette, and generates us a tile file that we can use to reference and then put those tile IDs into VRAM. You can also send it a full color RGB image, and it will disseminate that down into as few palettes and the correct color registers or values that the Neogeo accepts. So yeah, you can throw anything at it pretty much. So yeah, that makes the whole process of graphics conversion a lot easier. So yeah, let's have a think here. I'll go through the sync stuff in a bit, actually. There's no questions at the moment, is there? No, that's fine. Is everyone okay? No questions at the moment? No, it seems good. Right. So I think the best way to do this, assemble with Vasm, yeah. So yeah, I mean, you can have a look at the make file. It's pretty busy. So each of our demo parts are basically listed there. Oh, we've got C integrated as well. That's our tile assets. That's more to do with making sure that the dependencies are there for if those files change. Same with our fixed tiles, they're there as well. A lot of this stuff I don't really understand, but yeah, stuff. Don't really know how make works. But I do kind of, I'm starting to get this stuff down here. So this is where we do we like run is it Node.js scripts. I haven't. Okay, I've unplugged the 240 volts off of the desk now, Stephen. So yeah, we can run like Node.js scripts in here, so we can build anything. A lot of this stuff we've got in here is to like generate fade, like massive fade palettes based on the graphics assets that we've imported, and then obviously they are referenced there down there to know it needs to rebuild that if that changes. So. Hug Frank, what? Hang on, what's going on? Why are you crying, Francis? So, okay, I don't know why. Anyway, it's linked. Yeah, everything's all linked. So I'm not the best person to explain how this stuff works because I don't really know how it works. I was dragged kicking and screaming into this world, and now I don't mind it, but I have no idea how to build my own. So, yeah. So that's our make file. That's our tiling or graphics conversion tools and stuff like that. So let's fire it up. Let's do a quick clean. Should be fine. No, I'm not going to install a package for that. That's fine. And let's just do a run, a build. Oh, I tell you, there is a bit of tooling that we have got that we borrowed off of the. We found it online. Well, I mean, Daniel Collin or Emoon had to fix it because it was broken for Windows, and he did. So let me show you. It's one of our debugging tools. I tell you what I will do first. Actually, is I know I appreciate the music and everything, but when we're doing this, we don't really want to hear it. So. Okay, so you'll see ngdev initialized. We didn't write this. We just found it online and then implemented it in our environment and started using it. But so that's this great feature. So look for the help. We've got these functions we can switch on and off. So we do sprite bounding boxes, and you'll see all the sprites and how they're being used. They're very tall, those ones, aren't they? Oh yeah, they are tall, that's why. It's really handy for this when you've messed stuff up, so. But yeah, we didn't write this, we just borrowed it, but it's really handy to see like how many sprites you're using, everything that's going on. So hop pre-rendered cubes. So we will get onto that. But yeah, I just wanted to have a quick show of that. But yeah, this is very confusing, that one. Anyway, so yeah, Ferris raises a really good point there. So it's a 68,000 CPU running at 12 megahertz. And because it's mostly pulling the sprite and graphics chips are pulling on those ROMs themselves, and we don't have access to them, it means it didn't actually use that gigabytes. You should have done. It's really handy. Yeah, it means that you don't get any contention with DMA. So actually, the 68,000 is pretty much free to roam. So it's I think we're all finding it a touch faster than a 68,000 on an Amiga, because yeah, you just go, oh well, I wrote loads of bad code with lots of moles and divs in, and everything still ran in a frame. So yeah, but yeah, so I think it's like not DMA constrained. It's basically like a walled garden setup, right? So you can only talk to the Z80, which drives the sound chips, via like 1 byte out and 1 byte back. And the Z80 has what its stuff. It can talk to its own RAM. That's pretty much all it can do. Oh, and talk to the YM chip. And then we can talk to VRAM and palette RAM. And then that's it. That's the only things we can talk to. So all the sprites we can't touch. The fixed tiles we can't touch. Which means when the DMA is working for the sprites and the graphics and stuff, we're not getting in the way. So yeah. The problem is there's a lot you can only do in the Vblank though. Yeah, so that's a really good point. So because when that stuff's running, yeah, in the Vblank, so the Vblank, if you don't know what that is, it's the area that you can't see that's at the top of the screen. And then when this display starts working, everything's kind of running. So you can update a lot of sprites. We'll get onto one of those scenes in a bit. But you can't write to the palette RAM during active display. And it's literally no. So the problem is that every single pixel that the graphics display is picking up and writing reads the palette RAM. As soon as the 68,000 writes to the palette RAM, it then picks up what you're writing to it. So you can't write. Yeah, we'll get onto that. Yes, you can't during active display. You can't write to it. But yeah, you'll see there's a part in this that's incredibly fucking busy with that stuff. And yeah, there's 64K of RAM, like general purpose RAM as well, which obviously we ran out of pretty quickly. So I know it took us a while. So I did see a new person here. Can Mom, hello, first time revisioner here. I don't think we met, but I'm excited to get more involved in demo scene stuff. Well, welcome in. It's probably a great place to hang out. It sounds like you could do some blast processing. Well, you can't because you've got no DMA, so there is effectively no DMA at all, I think. So fresh meat for the grind. How are we doing for time? Oh, another 10 minutes. Has anyone got any more questions before we start delving into the various parts of the demo? Oh, you get while it gets to the hop, like the sprite generator has got access to the sprite ROM. We do not. So, like the audio chip, the YM has direct access to the PCM ROM. We can't read that at all. So yeah, as I said, it's like it's like these separate walled gardens that you can basically just do a little bit of writing to, and they go off and do stuff. So, right, well, let's do this in how are we doing? 10 minutes? Yeah, it's fine. Right, so let's just fire up this one. We haven't got there yet. So we'll see how many we get through. So the first one's dead easy. This is actually the first one that I wrote. Right. We'll just pause it there. So this is basically made up of two 512 by 512 sprite layers, right? And they're chained? Yeah, they're chained. So like basically you can just move the whole 512 by 512 with like a couple of VRAM writes. And there's two of them. So what you end up with is a count of, let's have a look then. Standard. That should never be on standard. programmer, thank you. So 32 plus 32, which is 64, right? So 96 minus 64 gives us 32 sprites left. So oh, Ferris, yeah. So how is chaining described? So the Y position controls obviously the Y position of the sprite and how tall it is. And it's got a special bit in there called the sticky bit, which is, it's lovely, isn't it? So basically you'll have a sprite that has a Y position, so like a word that has a Y position and the height, and then the next slot basically you just put $40 or hexadecimal 40 in there, and then it just attaches itself to that sprite, and then again and again and again and again until you put a different sprite that isn't chained, and then that one basically breaks the chain. So it's really easy to do, yeah. You just basically put the first one in, and then the rest you just set to 40, and then boom, done. Yeah, it only works in consecutive because then obviously they stay on the same level then, don't they? On the same priority, otherwise they start disappearing underneath other things. So like a linked list, yeah, but they have to be in the right order. Right. Yeah, so this is pretty wasteful in terms of the number of sprites, but it doesn't matter because we've got 32 left, and our screen resolution across is 320 divided by 16. So we only need 20 sprites to basically fill the whole thing up here. So what was that? Oh no, it's fine. Okay. Yeah, so we've got plenty of space. So this effect is dead simple. I can't hear it, but here we go. So this one, let's just boop, boop. There you go. It's dead easy, this one. So all it does is basically read the sprite's position and its shrinking value, and then we basically split it into slices like that, and just move them like that up and down, and then set the shrink value on them to gradually reduce them in the X. So that's just one value in VRAM that you just, and then they shrink like that, and then you move them out of the way. It's dead simple, but super effective, right? Once you get the ordering right. So right, so again, this is a strange one because these parts are kind of chained together. Linford, thank you. Yes, I was really pleased with how it came out, actually. And now these are basically your classic Z distance projection, blah blah blah. But again, if we look at them like this, you'll see they're taller than they look, right? So you can see that 206 there, 207. That's two of them there. So like, it must be 64 across. It looks like 128 tall, right? So right, what I'll do is let's go back to the project and let's go to our assets. And what did I call those things? Tube something else? Tube sheet. Okay, there you go. So bam. There you go. So it's just a giant sheet of basically pre-rendered them all for all angles. I would fire up Blender, but Blender runs really badly on here. But yeah, I didn't really know how to use Blender, but I had a pop and managed to get these out of there. A lot of editing and stuff, but they're basically like slices of 32 by 128, I think. Yeah, I think so. It must be, yeah, it's ROM unless you're composited from multiple sprites somehow. Exactly, yeah. So yeah, so pre-rendered for all the angles, but then using the sprite shrinking to basically make them smaller. So you can't make things bigger than they are. All you can do is shrink stuff. So it's like it's the magic stuff in the back pocket that it's got really on the Neo Geo is the shrink, because you can do so much with it. But again, it's only one direction. So I'm not trying to reference a terrible boy band in the UK. So can you make them more than 2x smaller? You can shrink them down to near zero. It gets a little complicated when they're chained and they're across. I probably won't go into too much detail on that, but what you get for one strip is a 4-bit value for the X shrink and a byte value for the Y shrink, because it's obviously 16 by 512. So you can like basically take a massive strip and then just so. Thank you, Graphic. Yes. Yeah, so you can shrink them down to near nothing, basically. Stuff gets proper weird when you like chain loads of them together and have a big area. So, Hop, are we using fixed tiles for anything? Yes, we are. Not as much as I thought we were going to, but there are a few bits in there. So we'll get onto those anyway. So that's basically how those bits work. It's not super complicated. It's just basically that there's a bunch of pillars put into 3D space and then projected to determine their position and height. So yeah, exactly. Yeah, thank you, Hooverphonic. Yeah. Right, let's turn the thing off again. Is it crashed? No. Oh, and this one's dead simple. Let's pause that. It's just a lot of sprites, 16 by 16, and this is where we get to the one of the bigger sprite sheets. Neversoft, did we uncover any undocumented hardware tricks? No. Oh no, the one thing we did discover is Sprite Zero is already it's always above all the other sprites, and it confused pretty much everyone until I told them to stop using Sprite Zero. But it's not documented on the. I can't see it documented in the wiki at least. But I don't know if it's somewhere in the documentation. But it's not. It wasn't. I found out the hard way, and I think everyone else did as well. So yeah, it was fun and games. So off by 1 errors. Yeah. Great for a mouse cursor. Yeah, I think they probably use it for like maybe the Mahjong games that you can get on the Neo Geo. But yeah. Right. So this is a blag. This is just a path that I built in Blender in 2D, and it doesn't. I mean, it's not very pretty. Let me show you this. So this is in Cube Vibes, and again, you know, we've got plenty of ROM. Cube path. There you go. Just exported each X and Y position across that path, and then did another one. Yeah, so not, and then just offset those paths to create 4 lanes of them. So, yeah. Does the code run from ROM? Yes. Yeah, because we've got like there's a megabyte, well under a megabyte, but there's a megabyte of ROM for program and data, or the PROM. Yeah, and that's all in ROM. There's only 64K of RAM, so. Yeah, you can't put anything in there. So, okay. Oh yeah, and of course you.
Still, despite their rivalries, Spectrum and Commodore owners could unite on one key issue, and that was that the owners of the third system, the BBC Micro, very much the liberal Democrats of the computer world, they were dicks.
There you go. Thank you, Charlie, for that lovely insight. So those cubes. ZX birthday today, is it? Oh, very nice. So, okay, so the cubes, obviously, this is fun. Let's go to assets. Is it cubes dithered? I don't even, there's so many of these in here, I don't even know which one's which anymore. There you go. Oh, we don't use those anymore, do we? Is this these now? There you go. So there you go. That's basically satisfying. Yes, it is, isn't it? It's very long. So obviously, if you have rotations of 16 steps, that's 16 times 16 times 16, which gets you 4,096. And then that's yeah. Basically, we've got 4 bits per rotation on this. So you can basically generate that into 3 values and then just double it and then go into our tile list and pick out which rotation value you need. But yeah, it's obviously 16, but then obviously if you go whoop, oh, that is really satisfying, isn't it? So there's probably some duplicates in it, and actually I think it's I think we might dedupe these as well, but see, I didn't make this stuff. This is just, I think it was Gigabytes who rendered these ones out. Let's have a look. I've got to go to the end, haven't I? Yeah, so you can see there, like, if you look at that last strip there, bam, it loops around. So yeah, pre-calculated, but then, you know, what are you going to do? There is literally, you know, there's nothing you can do. You can't, like, there's no frame buffer. You're not going to draw vectors. You couldn't loop it. Well, if you probably could, but there you go. That's a bit much though, isn't it? So yeah, it's like you just, once you calculate the rotations, you have put them in. Imagine like an RGB value on the Amiga or the OCS. It's just 16, 16, 16. So it's the same as that, except it's XYZ rotation. And you just pick it out of here, and then great. So this here is basically just there's quite a lot of them here. I can't remember how many I set it to. Let's have a quick look actually. So this gives you an idea of how many items you can like do some operations on. So cube vibes. Here we go. Oh, so it's 32 per lane, right? So I mean, I know you lot have already done the maths for this, but 32 times 4 lanes is 128 cubes. So we're doing like 128 delta adds, and then setting those sprite tiles and then loading them into VRAM. So yeah. Neogeo TF060 could do it. No. It's not even real time. Pathetic. I know, Terrible Fire, but you know. Obviously, it's one big texture moving over time. Well, it's just they're just oh, we still got them open. It's just a lot of where are the shaders? They're probably in scripts that generate this stuff. I don't know. You'll have to ask Gigabytes how he did that. He generated all of these sprite sheets to do with the rotation of those cubes. I just stole the sprite sheet. There we go. We could have used the sprite number of sprite tiles by using sprite mirroring, which I don't think we have mentioned yet. Oh no, we haven't, but didn't need to. Yeah, our tile ROM was 1.5 megabyte, and we've got 16 megabyte to play with, so we just didn't bother. So, oh, there you go. He generated it with a Node.js script. Yeah, so it was you know, he's good at that stuff. I'm not so good at that stuff, so. Right, let's carry on. How are we doing? Oh, well, great. I can go get a beer now. The scales solid sprite to make horizontal strips. Well, we'll get to that, I think. So, right, you're going to get X copy now. I'm going to go get a beer and make the wife a cup of tea. Back in a bit. There we go. Yeah, I'm sorry if the breakbeat starts. I just have to leave it. So, because I really like that part. If I get back before it starts, then I will interrupt it. So, anyway, welcome back, everyone. We are tearing apart. Oh god, that's the sync script. We should explain that, but not on that one. I think that looks like a right mess. Sorry to hear you broke your beats. Yeah, I know. Yeah, I've got to take him down the garage, mate. I think it's probably going to cost me about 700 quid. So, it told me that yes, that is true. JC1980. So where were we in the grand scheme of the actual demo at present? Let's have a look. Oh, here we go. So let's just we explain these. These are just there's just a lot of sprites, a lot of referencing. Background's still doing that thing. So yeah. Why does it do this? It's very annoying. Oh yeah, now that is that shut itself now, isn't it? Okay. Okay, and this is I did a lot of building then. Why was that building stuff? I haven't changed anything. That's worrying. Okay. Anyway, we've got fast forward in this anyway, which is really handy. Bam, bam. Okay, so this part is actually a good example of one of the few times we use the fix layer. So the layer of characters that sit on top. So we do that and then that. So you can see here, there's this dither pattern here. I was incredibly lazy with this. I did actually just do a 320 by 224 image and then let the tile tools basically just dedupe the whole thing. So I could just load the image in. So, Davros, yes, this is Neogeo. We're tearing apart or walking through the various parts of the demo, explaining how they work. Graphic. Apart from the code magic, the graphics in this demo are amazing. So yes, this is a really good example. And it actually caused me a bit of a problem. So this is actually a 64 by 512 image. So we're going to have a look here in assets. Assets, flow, it's F, isn't it? There you go, there it is. Look at that in all its glory. But it loops round. It's like been designed to basically, you can just like loop it all round and stuff, which is great. But this is one of those few times that we also used the sprite flipping. Where's MAME gone? There. So basically it's the same image, just loaded in reverse, utilizing the sprite tile flipping that that it can do, right? So you don't have to generate more tiles. You just tell it to load them in reverse and flip them around. So this is a good point where we could just go to, where is it? Data. So if we go to that, here, okay. Reveal in File Explorer, and let's just HXD. There we go. Just load that into there. So this is like a tile output that we get, a binary output. That tells us how many palettes this image has, how wide it is in tiles, and how tall it is in tiles. 20, is that? Yeah, that is right. So this image, out of the original image we have, has generated a total of 84 palettes. Palettes like 16 colors. So all the tiles reference different palettes. It gets a bit crazy. If you look down here, you'll see. I think that's a tile number in the ROM. That's a palette number offset from 0. So yeah, lots of palettes. So the pics are dithered as such and not normal pic stripes, and the dither sprites above them, I take it. So where's the image gone? So the black dots you've got here are the fixed layer, the 8x8 characters that you cannot move. So we just overlay that, and then it basically, we can block out stuff with it. So a sprite tile. So a single tile can be it can have 16 colors, but you can have a sprite is made up of different tiles that can reference different palettes. So actually, like 512 down could be whatever that is, 32 different palettes that it could reference. So right, so we remember that. What was that number we had? Calculator, yeah, there it is. So 84 palettes, and we can use it is a bit of a kicker, the palette thing. It's very tricky to get around and work out how to use it. So so what was that? 84, I think it was. Can't remember now. 84 palettes, right? So the question is then, how do we do this scene with 16 different levels of darkness when we've got, how much is it? 84 palettes, and we can only really reference 256 palettes at a time. Well, the trick is you make another version of the image that's got reduced color set and then create fade palettes for that. So it's a black. So and this is basically just a lot of sprite positioning and sprite shrinking. So I wonder if, and where was that? I wonder if palettes can be used for dynamic lighting of cubes. I mean, basically we did though, didn't we? There we go. Right. Okay, it's the first part. This one's by Hooverphonic. So actually we can do that. Then this is a weird one. You see the sprite numbers at the top here? You see they're flicking between two sets of numbers. So we've effectively got, let's just run that again. We've effectively got 4 layers that are being filled up, and we're basically double buffering them. So it's one of the few instances where we can write sprites during active display, because you're not looking at those ones, and then you just switch one off and then switch another one back on. So well, you just don't get Davros. You just don't get a playfield or a frame buffer, basically. So you have to do everything with sprites, but you can't modify the sprites in real time, apart from stretch or shrink them and change their position. So it's tricky. Right. Right. Now we need to talk about this thing, right? Try and get a decent. Why does it have to go dark? That's very annoying. So this is Gigabait's creation. So I did a sprite chunky mode that was basically playfields for the week. Yes, Terrible Fire. So I did a basic proof of concept sprite chunky mode. So basically the principle is you create a sprite that tile uses a set number of colors in a reference palette, and you create a lot of them, and then you can fill the palette really quickly and then change every chunky pixel within that sprite display every frame. And I can't remember what the number was I got to. Was it like something like 60 by 48? I can't remember now. But you remember I said earlier the palette thing, you can't write to palettes when you're during active display because it goes wrong. So I managed to squeeze I think it's like 200 palette writes in the Vblank at the top. But it wasn't good enough for Gigabytes. So he wanted to do something which loads palettes in the inactive display on the side of the screen. This was very tricky. So the way it kind of works is, see, because I didn't write this, so I'm not 100% on it. I know kind of roughly how it works. But basically the sprites are shrunk. Is that right? You shrunk the sprites so that you could get more sprites, more palettes within a 16 by 16 area. Yeah, so that's one of the tricks. The other one was in the Vblank, it loads the first 200 or so, or however many color palettes we need, and then as the display's running down, at 1/4 height. Okay, Christ, that's a lot more then. Yeah. Okay. So as it moves down, I suppose what I should explain is there's two palette banks. The 68,000 can access all of them at all time for writing and whatever. But the sprite tiles have a bank switch that as soon as you switch it, all the sprite tiles are then using this palette bank or this palette bank. So the way this one works is during the Vblank, he very quickly loads the first palette bank down at the bottom half, and then tells the display to use that palette bank for this half of the screen for the sprites. Whilst the display is running, in the edge of the screen, we're loading like a chunk, I think it's like, I don't know how many it is, like 8 or 10 colors, isn't it? On every raster line using a timer interrupt, which is an absolute nightmare. And then when we get to halfway, we finish loading the second palette bank, and then we flick a switch, and then the sprites start using that palette bank instead. I think that explains it. It's a tricky one to get right, and it's been a fair bone of contention because MAME doesn't support the palette issue. It's not quite that. I thought it was. I will have to get him to write in there. So no, well, we've got a timer interrupt. So the timer interrupt can so there's a few ways you can use it. You can tell it, you can trigger it to say wait for this number of pixels. It's racing the beam to fill the current palette bank. You can only set colors on the active bank. Oh. Okay. I mean, that's even crazier, but yeah, fair enough. So yeah, this was a freaking nightmare for two reasons. One, the issue of loading the palettes via the 68,000 during active display isn't emulated in MAME at all. So Gigabytes did it. Switching back for the fourth interrupt should be too, and switching back and forth in the interrupt would be too slow. Okay. Gotcha. There we go. Oh yeah, of course. Okay. Fair enough. So the overheads, well, we trimmed it down as best as we could. It was pretty good. So the interrupt kind of starts about here, and then does its like build up and reads data, and then the color loading kind of happens about here, and then it's finished by here. So yeah, it's pretty nasty. But then you have another technical issue that if you run, say, a multiplication here, that pushes that interrupt to trigger kind of a bit over here, or maybe over here, and then swings over here. So it was really tricky to get this one right because MAME doesn't support the palette issue that we would see on real hardware, and the timings are slightly different in MAME. So we basically had to put our timings in for the interrupts, and then just keep tweaking them until the garbage on the left or right hand side of the screen disappeared. So yeah. Oh yeah, and you'll see these little blanking spots. He slightly ran out of time and then had to hide his tearing at the top and bottom. So, which is great, you see. Yeah, all CPU. So there's no copper list. Later subbing, mate. Thanks for tuning in, mate. No. And then the voxels again. You'll see they're the 16 by 16 cubes. This just loves to die if you just leave it paused, doesn't it? I mean, it's just easier to close it, isn't it? Yeah. Get rid of that. But yeah, that's the heaviest of all the scenes, basically. Okay, yeah. Yeah, I'll explain that. Yeah, that's 4 layers of double buffer. Okay, we've done the voxels. Okay, yeah. And this is dead simple. It's just a lot of sprites and a bunch of values and matrices in RAM. The one thing you will notice about here is that the sprites suddenly disappear like half height. Just do that again. Okay, not to go too fast. Sorry about the flashing of the screen. So you notice here, come on, they're 2 across. I think they're 2 across and 2 tall. So it's yeah, 32 by 30. No, 16 across and 32 down. So 1 across and 2 down. So that just makes sure that you obviously they can. Why does this pause just die? This is so annoying. Oh yeah, Gigabates can explain that. Here we go. So they just occupy the whole space. You could optimize this to use less sprites, but that was about the limit it was going to do. But if you watch here, about here, you notice that they're now all half the height, because as soon as this starts coming in, basically you run out of sprite limit across. So that's how you do the transition without it completely ruining all of the sprites that are currently on screen. How we do that? Half past, bloody hell. Flying through, aren't we? Right. Yeah, sorry about the flashy stuff. Yeah. Nice. So slightly complicated in the transition there because I had to do stuff that means that 2 parts were kind of running at the same time, but that's just technical stuff you have to work out. And then you lot saw this on stream about 3 or 4 weeks ago because I did the prototype of this on stream because I just wanted to, but obviously this is the finished version with all of the sync and everything. And then when we get to here, there you go, that's a fixed layer clear, so we're just putting fixed layer tiles over the top, the stuff you can't move, like a blanking character. Oh, here we go. Right. So this is the bugger, right? Right. This scene was made beautiful by the man that is called Made. It's fairly simple, but a pain in the ass to get right. So this is made up of. Can we show you? See there? So we've got like a whole image here that actually goes all the way down, so it fills the whole screen. So this is the original full image, and then we've got a separate layer here, it's actually dead simple, right? All it does is we trigger a timer interrupt for sprite modification. We don't necessarily need to do it anywhere particular. It doesn't seem to matter where we do it on the line, but you have to do it 2 lines ahead. So all this is doing is basically we've got 1 set of sprites up here and another set of sprites here, and then what this is doing is it gets to this line and then it starts modifying three values on the sprite. So it modifies the X position, it slightly modifies the Y position, and then it also modifies the shrink, but it's doing those with like tiny little values of sine basically. Thank you, Ferris. Yes, it is. So yeah, it doesn't quite emulate the position on here. If we look at it, it's probably crashed now anyway. Of course it has. Come on. Bam. Okay. So where is that? Poolside. There is something else very interesting about this. That was a little hack that we found at the end. I don't think this is the nicest. Oh yeah, so this is the calculation for... Oh, that's the reveal. Fade pre-calc. Fade run, blah, 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 fade run. We've got, what's it called, tick in here? Waterline tick. So that is the code that runs every raster line when we get to that point. And it's basically, I could have optimized this a bit better, but it worked, and so that's fine. But it basically sets a position in the VRAM, and we've got like a table of that you fill up of various values. So SCB4 will be the X position. Then for some reason I do the shrink value, and then I do the Y value. But because that's on the interrupt, you want that to be as slimline as possible. So it just basically picks up the pointer, writes in a bunch of registers in the VRAM for that sprite ID that we're doing with, and then jumps back out again. Did we do anything else? Oh yeah, because it's a thingy sprite, so that's fine. Oh yeah, water slot. So we've got one slot for that sprite, and they're all chained together. So, and that's basically how it works. It's just basically just getting the right values in for the sign of the shrink, and then the X was just a tiny little bit, and then because the shrinking was like pulling it towards itself and then expanding it again, it would eventually just be a bit too small for the screen. So we had to put a Y increase on it as well to push it a bit further down the screen. Otherwise, it would just basically run out of image. So that is basically how that one works. Does the H-blank time change based on how many sprites are on the line? No, not at all. The only thing that can mess with that is it an actual it's an actual interrupt. So the interrupt can be timed. Actual interrupt. Yeah. So you can operate in it different ways. So you can tell it to wait a set number of pixels and then it will trigger. You can tell it to wait a set number of pixels, but reload that number of pixels at the start of the Vblank. And then you can tell it to reload every time it runs out with a set number of pixels. So it was actually a bastard to get right, because I eventually put that into a function that we could just use. We could say we want to start at this line, and we want to, and I'll give you a pointer to a function that I want you to call every 1, 2, or 3 or 4 lines, and then it just does that stuff for you. So yeah, a pig to get right. But yeah, there we go. Right. But yeah, the reason why this scene is so good is mostly because Made's graphics is bloody fantastic. I mean, the water effect's lovely, but that's nice. But yeah, again, without a copper, it's quite hard to do. Oh, here we go. Now, I can't really fully explain this. What I can tell you is that Emoon and Made designed these scenes in Blender and then exported them so they had full lighting. So when those switch on, that's basically it's calculated by Blender, and then that affects the lighting on the cubes. And there's a whole bunch of other stuff to do with them floating behind those pillars and in front of those pillars. And yeah, that's how that works. Debris, yes, Dark Star. That is kind of the idea where that kind of came from. So I don't know if Daniel Collins is still there, but yeah, I've basically the pillars are fixed layer, yeah, so they're on top. I did lots of Blender scripts to get this sorted out. Yes, that's how I'm going to tell you, right? So what he did was spend 5 weeks on 14 seconds of demo. I think that's about right, isn't it? And this is just basic as hell. Oh yeah, Daniel Collin did work. Emi did work on something first. That didn't make it because he ran out of sprites very quickly. Yeah, that was a bugger, wasn't it? Spent a few weeks on that. Ferris, yeah, that's true. But yeah, it was quite spirit crushing for him, man. Like, it kind of sucked. Like, I'd seen him working on it, and then he got like a little prototype running on the Neogeo, and I was like, oh, that's going to be quite cool. We might be able to use that. And then he put another, like, he's trying to use it to like generate these like shapes like that, and yeah, just instantly ran out of sprites, and then decided to drop it. So yeah, seeing someone do a few runs, and then yeah, a bit of a false start. It's hard, man. It's really hard. But this is the thing. You have a go at something, and then yeah. It's just how it is. Sometimes things don't work out. You think you might be able to do it, and you try it, and it fails miserably. It's just the hardware won't do it. So, yeah, I suppose that's the big difference between stuff on this platform versus the Amiga. The Amiga, there's a 1,000 ways you could skin a cat, right? You've got sprites, not very good sprites. You've got sprites, bit planes, multiple bit planes in different levels. You've got a blitter. You can line draw. You can fill. You can do all this stuff. You can't do any of that here. You have to generate your sprites and then just show them on screen. There's like loads of ways you can do stuff, but there isn't so much. There isn't loads of ways you can do stuff. There's just a few ways, but then you've just got to work out how you're going to do it. But yeah, it's all sprites. So yeah, I think that's pretty much... oh no, I didn't... I'll tell you what I didn't explain. Which is, let's go to scene 1. This was an addition that Emin put in, which was an absolute lifesaver. So this is our sync script. So I'm sure I'm going to explain this incorrectly, but basically you can have multiples of these running all over the place. You can have them in different bits of code, anywhere. So basically what happens is you init this first, and then you say this is the intro logo where the logo is kind of split apart. Pardon me. So this waits for sync bar 0 sync beat times 2. Oh, thank you, Graham, mate. Welcome in. And then this is just a macro that you have to put together, and then that will basically wait to there until this timer has been hit. Basically, this point within the music, so 1 bar and 2 beats, and then you can run this bit of code, and then you put this one afterwards, and it will basically just wait here. But the benefit is that when it jumps in, so you call this sync text every frame when your code's running. So rather than running through all of these steps, when you move to the next step, it remembers that, oh, this is where you were last. So this will basically just jump straight to here. And when you pass that one and do that sync bit, it then jumps down to this one, and then jumps down to this one, and then jumps down to this one. So this was a bit of a game changer for us on this, because it just meant that we basically, the way we did it is we also added this. So when you finish a part, which is 8 bars and 0 beats, I don't know why that's there, you do a sync store offset and say I finished, and that basically resets the music counter. So when the next part starts, the next part is starting at 0, and then you can write your sync script. So the benefit is that everyone writes their own their own sections, basically assuming that the music starts at 0, and then they can do their synchronization in that part, and then when we piece them all together, the sync on those sections all work. And there we go. Yeah, the sync stuff is based on Proto Head's concept that we borrowed from Trident C64's talk. Yeah. I wrote some initial sync stuff, and then I looked at this and threw it away. So, yeah, it wasn't good. A lot of worse versions over this. Yeah, but the thing is, you can in this scene 1 here, for example. So if we go up here, let's go to part 1. So that, and it's a sync script here called sync text and then sync stars. So, and then at the top of the loop, we're running sync stars and sync text. We wait a frame, we run the code for that frame, we test whether one of those sync scripts is exited. We don't, so it's fine. So we can run multiple of these, which means when we come to part 2, we don't need the sync text anymore, so that's the logos, but the sync stars, we just repeat that because we've already got it, and then we put the tube syncs in, and we get to part 3. Where's that? There. And this is complicated here because this has got sync stars 2, but then we run something over in cube vibes. Very annoying, but there we go. This part kind of got a bit convoluted with 2 sections of code basically talking to each other. So I won't confuse you with that. So can anybody smell toast? So and then just I suppose one of the last things we can pull up is well, let's just get that loading anyway. And then the other thing is, it was just a C# thing that I did on the side because I already had this stuff here, but we didn't include this in the build because, well, it's rare that we were changing stuff. So in terms of the music, no, I haven't got Lurgy. I've been talking for 4 days. I feel absolutely fine. So in terms of music, what we did is automated it splitting up in 8-bar chunks. So we can just pause that sec. So section 0. Okay, but then you get the whole tune after that, and then section 1, and then 2. 4. There we go. So, for example, I was doing the water effect on our spreadsheet. We have that as section 9. We've got timers against that and kind of what that section is been attributed to, what we're doing in that code, which means I can just drop. What happens is no, that's the WAVs. The ADPCMs sound really good, but they're in here. So what it also does is spits out WAV files for you. So you can just click on that and say, right, that's what that bit actually sounds like. 55.555, yeah. But what it also spits out is a couple of files here. So that's the ADPCM ROM file for putting into main, and then that is a specific Z80 ROM that is built with that file in mind. So basically, if you're working on a section here, I can grab those files, drop them in the ROM folder, and then the music will start from section 7. If I want to work on something else, I can grab another section here, copy those files into the ROM, build the demo, and then the demo starts the soundtrack starts at that point. And then obviously when everything's kind of pulled back in and everyone's got all their parts in, you want to go to section 0, drop those in, and then watch kind of how the whole demo works at that point. It just means everyone can basically just like drop some files in, put some code together, do their synchronization from a 0 point, get everything together, and then great, that works. Drop it in, just put it in as a BSR, and then everything just basically fits together. And I think, I didn't change anything there, okay. I think that's everything, unless I've missed something in particular. That's every part. I don't think there's anything particularly special after that. Oh, come on, Live. What are you doing? Is there a secret bit? Yeah, if you run it from real hardware or emulation or whatever, just leave it running. You'll see the secret bit. We'll run it again in a second anyway. But we can just do a couple of things here. Oh, there's the particles part. Of course. Great. Oh, great. How terrible of me. I don't really know how that works though. But let's just have a quick look at it once that's finished loading. There we go. Let's just get it up. Can you explain where it does the thing? Yeah, it does the thing all the time, like 60 frames a time through the thing. So let's just get there. Pause is probably going to crash it again. There you go. And then yeah, these are this is a particle effect that Gigabait's put together that basically is timed to within an inch of the frame. But again, that's like a lovely bubbliness. Yeah. So I don't know what he does with them. I haven't really looked at it. All I did is switch them off at one point. So and then just to wrap that up, he cut out the logo that says Vaporous there. So when we do that effect and then switch them all off, it does that. Gigabyte, so there's anything particular? Oh, we did go over the checkerboard earlier, yeah. Perhaps our main plugin for control the 68,000. I did do that right at the start, but yeah, we can just do a quick bit of that. So let's just go to scene 1. Let's go to. Let's just jump there. What constraints when coding this demo? Sprite count and sprite horizontal count. So you've got 380 sprites. If you put 380 sprites all overlapping horizontally, then you're going to end up with 96. Yeah, and you'd be surprised how quickly you get in there. So, it does the macros okay, that's fine. So this is our debugger. We can just basically step through stuff, which is great. And I think that does, yeah, we did, yeah. So that you can hover over stuff. You can set up watches here. So what are we doing? A4. So if we do A4. So if you watch here, that address changes there. You see it writing all those values in there. Fabulous stuff. Oh yeah, Daniel Collin also added debug stuff in the Lua stuff, but I'd never actually used it. So you can actually put. Have you got any in here? No, we haven't got any actually running, have we? Yeah, the particles part is 256 sprites rotating and moving up and out at random speed as they decay. And they need Z sorting to go in front and behind the logos and stuff. So, Neo Severa. I tried to do that today. I spent 5 to 6 hours trying to get it to run and be synchronized on the Neogeo CD, and it's not working. That's the only problem is getting the music sync right, because the sync is so tight on this that if it starts drifting out, it's an absolute mess. We might have a solution. There's a couple of things I want to test out, but that's the only thing that's the problem. The ROM sizes are all fine. The demo fits in the Neogeo CD, but we can't seem to get the music sync off of the CD quite right. There's something weird going on. So yeah, we might look at doing an ADPCMA soundtrack hack, but I'm not sure I'm fully convinced about the quality of it. So we'll see. I've got another trick that I might try. I might just try and record the CD off of the recording of the CD playing and saying and seeing if that works. Does this demo look nice on a CRT? Of course it does. Everything looks nice on a CRT hop. Not that I've tried it, but yeah. So oh, the speed plugin. I forgot about that. But I've always got the other one switched on. And we can't seem to have two plugins at the same time. So just to give you an idea of how quick we can start this up. So your make has done all the building. There's nothing to build. And if I change, I don't really want to change anything, but let's just change one bit here. And then build. Okay, see that built one tiny bit. So where's the launch? Let's take that off. So say for example I'm in main and I'm only modifying this piece of code, then I hit F5 and the demo is currently running, so it's not going to do anything. Let's try and demonstrate that again, shall we? So here I am modifying this piece of source code, blah 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 blah. Okay, I hit F5, builds that one piece, and then shoots straight through the BIOS thing. No, Neo Severa. All of the graphics in this are original. It's just isometric flaw. That's all it is. Gigabytes, Daniel Collins, Hooverphonic. Have I missed anything? I probably have, but we are desperately running out of time. But as I had loaded it, let's just have a quick look at this. It's probably going to be massively too loud. Ba-ba-bum. Not the most complex of live sets, but here we go. Reversing. Actually, this is the bit that I like most, which is this one here. There you go. It's nice, that, isn't it? No, I don't think these have been used. I got a lot of these off of Splice and some other sample pack that I bought. But then you get to the classic, where is all the bass is here, isn't it? There we go. Two-layer bass. And then it does the older. The thing is, you don't really hear that power when it's all, when everything's together. It's just kind of there. So yeah. You gotta have a race, man. You gotta have a race, and let's just. So yeah, it's just basically, it's an ADPCM stream. So you do what you need to do in Ableton, and everything's great. So FLP, Fruity Loop Project Studio. Oh, I did do that thing there, didn't I? So do you lot remember probably about 5 or 6, maybe a bit longer than that. I did one music production stream, and I did a sketch that sounded like this. Well, not like that, but well, it became the demo. But the Amiga has a benefit because it can do stereo, but it's 14-bit and 28 kilohertz. Whereas the Neo Geo is 55.555 kilohertz in mono. Long edit of nothing. Exactly, Ferris. Yeah. You just need that space there. It's like it's an extra 4 beats. It really kind of throws it out, but works. And also, I'd like to thank the stream for this one. I can't remember who suggested do the pitch down on that, but it was perfect. I think it might have been NE7. Actually, just this little bit here. I love this bit. Where is it here? Fine. Got a bit backwards with a bit of reverb as well. There you go. That's all of that shenanigans. So I think we should just fire it up. You can't get too comfortable with a track like this. No, you can't. Yes, I did notice that. It had to happen. Yeah, it was very good. Right, show me the retro. No, don't show me the retro. Let's just switch this on again and listen to Axel F, I think. Oh, no, yeah, okay, we've got to plug it back in here. Yep. There we go. See, it's like me queuing you up, mate. I put one thing in there and I know you're going to take the bait, so it's fine. It was super fun, mate. So let's play some Metal Slug 2, yeah? There you go. We made a demo about it.